You know, for over 70 years, our entire digital world, everything from the first clunky computers to the super-powered phone in your pocket, has been built on a single, really simple idea: binary logic. A world of just two states, 0 and 1.
But what if that foundation wasn't the only option? What if binary was just the path of least resistance, a choice made because of the technology we had at the time? That one question opens up a whole new world of possibilities and an alternative system that could seriously revolutionize computing as we know it.
So what's the big difference? Well, with binary, you've got two states, right? Off or on, 0 or 1. But ternary computing throws a third option into the mix: a middle state. So instead of bits, you have trits, which can represent negative, neutral, or positive. That extra state means a single trit holds way more information than a bit. You can process a lot more data in a single step. And what's wild is that this isn't some brand new futuristic idea. Nope. To really get its potential, we have to jump back in time, all the way to the 1950s Soviet Union, and a piece of computing history that almost everyone forgot. Okay, so picture this. Soviet engineers are facing this massive problem. In the US, you've got companies like IBM just pumping out computers, but the Soviets, they're building theirs by hand. Their machines were powerful, for sure, but they were crazy expensive and super rare. They absolutely had to find a more efficient way to build them.
So at Moscow State University, an engineer named Nikolai Bersentov teams up with a mathematician, Sergei Sobolev. Sobolev is the one who introduces him to ternary logic, and by 1958, they'd built Setun, the world's very first ternary computer. It was a total breakthrough, but, well, it was eventually abandoned because the rest of the world was already sprinting down the binary path.
Just how big of a deal was Setun? Get this, it costs at least 10 times less to make than similar binary machines of the time. On top of that, it was more efficient, using 30% fewer parts. I mean, think about that for a second. A machine that's more powerful, more efficient, and dramatically cheaper.
So, if it was so great, why did it just disappear? Well, despite being a technical masterpiece, Setun was an outsider. The Soviet Union didn't really have the political drive or the industrial backbone to scale it up. And at the same time, the rest of the planet was building this massive technological ecosystem. Software, transistors, you name it, all of it built for binary. Setun was just a brilliant idea in the wrong place at the wrong time.
All right, let's fast forward to today, because now we're staring down a totally new kind of problem, a binary bottleneck. And it's making this forgotten piece of history suddenly seem incredibly relevant again.
You have to wonder, is the system that served us so well for decades finally hitting its limit? Is the very foundation of our digital world being pushed to its breaking point?
And here's why this matters to you and me. The data centers that power our modern world, all the AI, all the big data, they are sucking up a mind-boggling amount of energy. We're facing a massive efficiency crisis, and binary computing, for all its strengths, might not be enough to solve it.
And this is where that old Soviet idea makes its dramatic comeback. Ternary computing is suddenly re-emerging as a serious contender, a potential answer to this binary bottleneck. The modern breakthrough comes from Huawei, who've developed a 7-nanometer ternary chip. Now, the real magic is in how they build their transistors. Instead of having just one voltage threshold to create two states, theirs have two thresholds. It's a simple change, but it's brilliant because it allows the chip to clearly distinguish between three different states. And the results are just staggering. Look at this comparison. 40% fewer components, a whopping 60% less power needed, and a 20% boost in speed. These are absolutely massive gains, especially when you think about the scale of today's AI applications. But okay, it's not all sunshine and roses. Ternary computing has some pretty big technical hurdles to clear. The main one is noise. With three states packed so closely together, even the tiniest little flaw in manufacturing can cause them to blur into each other, and that means errors. So building these things reliably, on a massive scale, it's really, really hard.
But this is where materials science might just swoop in to save the day. Cool materials like graphene and carbon nanotubes are showing incredible promise. Their unique electrical properties allow for much cleaner, more precise switching between the three states, which could solve that critical noise problem once and for all.
And just look at the potential here. The latest research on ternary chips built with carbon nanotubes shows they can handle the same complex AI tasks as a binary chip, but they do it using 30% less energy and taking up 45% less space. That's a total game changer for efficiency.
So, does this mean we're about to throw out all our binary computers? Well, probably not. The future is likely going to be a bit more blended. A new era where these two systems actually learn to work together.
Is pointing towards a kind of hybrid model? Binary isn't going anywhere. Still going to be king for general-purpose computing and all the legacy systems out there. But for the really demanding, power-hungry stuff, we're talking AI, massive data centers, even mobile devices, ternary computing could offer an incredible edge in efficiency and power.
What this all shows is that we're finally starting to explore what's possible beyond the system that has defined computing for almost a century. Just like those Soviet engineers imagined a third state all those years ago, we might be on the edge of a new era ourselves. So the question is, could rethinking the very foundation of computing be the key to unlocking the next great leap forward?